Alright, this is pre-algebra, or excuse me, Algebra 1. 3.1, we're on page 134 in your book. Okay, we're going to get into solving some algebra now, so we're ready for the fun stuff. Okay, inverse operations is the first vocabulary word, and it's the very first thing highlighted in your book on that page. They are basically operations, two operations that undo each other. For example, adding undoes subtraction, subtraction undoes addition. Multiplication will undo division, and division will undo multiplication. So one way to think of it is money, you have $5 in your pocket, and when you spend it or take it away, that undoes it. It gets rid of it. So inverse operations are important for solving equations. Equivalent equations are just basically equations that are equal to each other. Okay? And it can be as simple as just x plus 2 equals x plus 3. Something like that. You'll solve it. A reciprocal? Actually, it's just as easy as 3 equals 3. Could be an equation. A reciprocal is when you have a fraction and you take the fraction and you flip it over. Those are reciprocals of each other, and those will come in important when we're solving, especially when we get fractions involved, when we're solving the equations. So the first key concept box is right there on that first page. So if you guys will look at that, it says the addition property of equality. Okay? The addition property of equality means that you can add the same number to both sides of an equation. Okay? And it produces an equivalent equation. It makes it the same. So for example, we could take, let me do it with numbers instead of algebra, x minus 2 equals 5. To get x by itself, I could add 2 to this side, but the rule says I have to add the same thing to both sides in order for them to be equivalent. So those would cancel out. X would equal 7. That's what they're talking about. Now in that same box they have the subtraction property. So basically that says, how about if we just say you add or subtract? Let's not write that again. Add or subtract the same number to both sides. So here's a subtraction one. X plus 6 equals 10. Well, I know you all know that it's 4, but if you subtract, we want to get the x by itself, so I subtract 6 from this side. I also have to subtract 6 from this side because I have to treat both sides equal. Those cancel out. X equals 4. So that's how we algebraically solve those. And there's our first key concept box. So let's take a look at example number 1. What I do is, number 1, you got to write the equation down. I expect to see the original equation on your paper. So you write this equation down, and then you find the side with the letter. Our job is to basically solve this equation, and by solving it, it means to get the letter by itself. So I look at the side with the letter, and I verbally say it out loud. I say x plus 7. So to get the x by itself, we got to get rid of the 7. And we get rid of the 7 by using the inverse operation, which will undo adding. So the undoing of adding would be to subtract. So we would subtract 7 from this side. And from the key concept box, if I subtract 7 from this side, I have to subtract 7 from this side. The 7's cancel out. X equals 4 minus 7. And one way is to think of it this way, and I have even boom boom, that would be negative 3. We got to get used to seeing them vertically instead of horizontally, especially in algebra. And I would go 4, I just say 4 minus 7, I would boom boom right there, and then I can see that I would add. Nice thing about algebra is you can always check your work. Negative 3 plus 7 is positive 4. So that comes out nice. So let's see how they check and solve their work stuff going on here. So they write the original equation. Notice they minus 7 from both sides. They do it a little different. They show it right there, not underneath like I did. They show it off to the side. I don't like that. I'd rather you show your minus 7 underneath. And x equals negative 3, which is what we got. And then to substitute, just like we checked it, we put it back in, and we see if it works. Okay, so solving the equation using addition now, we find the side with the letter again, we say it out loud, x minus 12. So the opposite of minusing 12 would be to add 12. If you do it to that side, you do it to this side, those cancel out. X equals 15, we check it. 15 minus 12 is 3, and we're good to go. So let's see what they did. Horizontal. Ours is a vertical format, not the horizontal format. I think it's easier. That's the way I've always done it. Oh, here, they're going to show it over here. Look, plus to 12. I just think that's easier. All right, so go to your key concept box on page 135. Just like the adding and subtracting, if you multiply or divide both sides of an equation, I don't know how I do that, it makes an equivalent equation. Okay, so here is an example. 3x equals 12. 3 times x, the opposite of timesing would be to divide that by 3. If you divide that side by 3, you divide this side by 3. X equals 4. And the nice thing is, by picking problems like this right now, those are easy for you to see what the answer is, so you can practice the algebra. That's what we're doing right here. I don't really care about the answer so much as the process in getting to the answer. So check this one out. X divided by 2 equals 10. X divided by 2, and when I say it out loud, I know I got to undo that. So the opposite of dividing would be to multiply by 2, and I always show it by the dot, and I write a times over there, just like here. Those cancel out. X equals 20. So there's your key concept. I know I didn't put all the algebra in there, but you can follow what I'm doing. So I say this out loud: -6 times x. Well, they might not have done the, yeah, they did the division. Okay, -6 times x. So I have to undo multiplying by -6, which would mean to divide by -6. And I have to do it to both sides. That cancels out. X equals -8. So let's check it. Is -6 times -8 positive 48? 2 negatives make a positive, and 6 times 8 is 48. So notice they write the original equation, they divide both sides by -6, they come up with -8. Oh, wait a minute, back up. Okay, so we know the answer's 3, you just saw it, but we need to solve it algebraically. So you're going to write this on your paper. You have +7, so you're going to go -7 on this side, -7 on this side, cancel those out, y equals 3. 3 plus 7 is 10. X minus 5, the opposite of minusing 5, is to add 5. Those cancel out. X equals 8, and we should check our work. 8 minus 5 is, I don't know how that happened, is 3. Q minus 11, so you add 11. Remember, you're writing the original problem with me, not just the answers, and you're doing all of this. This is guided. This is for me to help you practice. So plus 11, we cancel it out, so you should cross yours out. Q equals -5 plus 11 is positive 6. 6 minus 11 is supposed to be -5. I boom it. I get -5. Now the letters on the right side, no big deal, it's just t minus 2, so you add 2 to this side, add 2 to this side, t equals 8. Check it. 8 minus 2 is supposed to be 6, and it is. You can switch the sides of the equation around. Okay, now we have some multiplication. 4 times x equals 48. What's the opposite of timesing by 4? Would be to divide by 4. The 4's cancel out. X equals 12. And 12 times 4 is 48. And it is. So we have some negatives you have to be careful with. We find the side with the letter. -5 times y, the opposite of timesing by -5 would be to divide by -5. And 5 goes into 65 13 times. And it's positive 13. I don't know where those lines come from. 6 times W, so you opposite of timesing would be to divide by 6. Negative and a positive make a negative, and it comes out to be 9. Negative 9. This one, 24. 24 equals negative 8, and so we're going to divide both sides by negative 8. The ends or the 8's cancel out. N equals 24 divided by 8 is 3, and a positive and a negative make a negative. Put it in right there to check it. Negative 3 times negative 8 is positive 24. So this is a division equation. Say it out loud. I always notice I'm not just talking because I have to talk to you guys and show you. If I was doing the problems, I would still say them to myself so I can get them straight. X divided by 4. The opposite of dividing by 4 is to multiply by 4. So I times this side by 4 times this side by 4. That cancels out. X equals 20. Put it in. 20 divided by 4 is 5, and it works. And there it is. Okay, so let's solve the equation for the guided practice for that one. It shows, there's a lot of guided practice. T divided by negative 3. So the opposite of dividing would be to multiply by negative 3. They cancel out. T equals negative 27. So if you put a negative 27 in right there and divide it by negative 3, you would get positive 9. So T is negative 27. C divided by 7. Remember, I'm always finding the side with the letter, saying it out loud. C, and don't say C over 7, because that doesn't tell you which operation is happening. C divided by 7, so the opposite is to times by 7, and I have to do that on both sides. That cancels out. C equals 42, and 42 divided by 7 is 6. Z divided by negative 2, so you times by negative 2. So those cancel out. Z equals negative 26. And negative 26 divided by negative 2 is positive 13. A divided by 5, so you times by 5 on both sides. That cancels out. A equals, negative 55. Didn't we do example 4 already? I thought we did. Divided by 5. Guided practice. We did all that, didn't we, guys? We did. Must have duplicates in there. Sorry. All right. Example, where's example number 5? All right. Sorry, it looks like example number 5 is not here, so we're going to stick it in right here. Example number 5. Watch and learn. Look at this. Negative 2/7 x equals 4. Remember when we were talking about the reciprocal before? I said we'd come back to it. Here's where it is. Now, this is hard because this is negative 2/7 times x. So the trick is whenever you have a fraction multiplied with the letter, you want to get rid of it. And notice the letters, when we're getting rid of it, the letters are just by themselves. There's just one letter there. So technically you're making the number go to 1 that's with the letter. So whenever you multiply a number by its reciprocal, it will go to 1. So you take negative 2/7, you multiply it by its reciprocal, which is negative 7/2, and look at what happens here. 2 negatives make a positive right here. The 7's cancel out, the 2's cancel out, and the x is the only thing left on that side, which is what you want. And then you multiply this side by negative 7/2, because whatever you do to one side, you have to do the exact same thing to the other. You can cancel the 2 and the 4, and it comes out to be negative 14. So anytime you have a fraction with a letter, you can multiply by the reciprocal to solve it. Okay, so let's take a look at one here. Oh, wait. Guided practice for example 4. We're still doing number 12. I don't want that one. They don't have the, do you notice? Here's example 6. Example 4. Okay, so let's do the guided practice for example 5 right here. Number 13, write with me, 5/6 W equals 10. Okay, so we have our fraction with our letter. How do we get rid of a fraction? We multiply by its reciprocal. It's not negative, so we multiply, just keep it positive. Those all cancel out. And if I multiply that side by 6/5, I have to multiply this side. Cancel the 5 and the 10. The answer is 12. Okay, let's do number 14. 2/3 P equals 14. So we multiply by the reciprocal, which is 3/2. This side by 3/2. And sometimes it's better to write them on both sides so you don't forget what the reciprocal was. 14/1, cancel, cancel, that goes in there once. 7 times, that would be 21. Okay? Number 15, and this is guided practice right here, so you're supposed to be doing these, and I want to see all of that. Don't just write 21 and watch me do all the work. I want you to practice it so you can look back when you do it when you're doing your assignments for help. Okay, 9 equals -3/4 M. So again, there's a fraction with the letter. We multiply this time by -4/3, which is its reciprocal. Multiply this side by -4/3. Those all cancel out. 3 goes into 3 once, 3 goes into 9 3 times. -12 equals M. So that one works. We're good to go. Number 16, the last one for this one. -8 equals -4/5 V. Times by -5/4 times by -5/4. The reciprocal, remember? 8/1. 4 goes into 4 once. 2 negatives make a positive. +10. You get good at it. Just practice. Takes practice. Okay, the last example, example number 6. In the 2004 Olympics, Sean Crawford won the 200-meter dash. His winning time was 19.79 seconds. Find his average speed to the nearest tenth of a meter per second. Okay? His average speed. So this is distance equals rate times time. He went 200 meters is his distance. We want to find his speed, which is his rate, and 19.79 seconds. So that's R times 19.79. How do you solve equation if it's times? We want to get rid of that, so we divide by 19.79. So 200 divided by 19.79, and I think I would use a calculator on that one. It comes out, it says approximately 10.1 meters per second. I think we should put the slash probably instead. There's our distance formula. There's that dividing. Case number 17. What if in example 6 they ran 100 meters at the same average speed? He ran for 200 meters. How long would it take him to run 100 meters? So he's running 10.1 meters per second. Round your answer to the nearest tenth. So now he's running 100 meters at 10.1 at the rate of 10.1. Now how much time? So divide by 10.1. 100 divided by 10.1 over and up. 101, which would be 909, right? Am I doing that right? 909, yes. Borrow 1991, add a 0, bring it down, goes in there about 9 more times. 909, that's really close. So approximately 9.9 seconds is how long it would take him to run 100 meters at the same rate he runs 200 meters. Alright guys, there's a lot of stuff in there, but please show all of your work. Make sure you take that time and show your work on all those equations. Write out the answers and write out the original problems and show what you do to both sides. Please ask if you're stuck, and we'll see you next time.